Hi students, let us have a discussion on the subject network theory from GATE exam perspective. So there are three aspects I'll cover in this video. The first one is what is the syllabus content of the subject network theory. Secondly, what is its weightage in the GATE exam. And at last, what kind of questions or the pattern of question in the GATE exam from these subjects. So if you one by one will see. So if you go through the official website of GATE and if you check the syllabus of networks, so 4 to 5 lines they have specified, and I have just elaborated those content into 16 topics or 16 chapters basically. So in fact, if you go through any standard textbooks like Alexander Sadiku, Haight Kimmerly and all, you'll find in their book around 25 to 30 chapters are there. But I have classified them into 16 topics, and this is the sequence if you follow to learn these subjects, your transition will be very smooth because certain topics are there which are interlinked. Unless until you don't have the background of the previous topics, so you may not be able to grasp the concept of that topic. For example, if you want to learn the concept of transients, unless until you don't have the basics of inductor and capacitor, so it is baseless to learn this particular topic. So like this, the sequence you should maintain while learning this from whatever the source you are learning these particular subjects. Okay. So now one by one we'll see. So first let's come to the syllabus. So the entire syllabus is classified into 16 topics, namely fundamental of networks, network theorems, fundamental of capacitor inductor, step or DC response of RLC network, network concept using Laplace technique, two-port network, sinusoidal steady-state analysis, parameter of AC waveform or time varying waveform, AC power analysis, electrical resonance, filters, locus diagram, AC transient, phases, magnetically coupled circuit and three-phase network. Let me tell you students, among these 16 topics, so your majority of the question you get from the initial 10 topics itself up to resonance. These 6 topics, filter, locus diagram, AC transient, phasor, magnetical coupled circuit, three-phase network, the weightage of these topics are very, very less. I can say in every 2-3 years, one question you may expect from these 6 topics. So majority of the questions are from the initial 10 topics only. So this should be in the top priority. You should learn each and every point and concept of the first 10 topics. Okay, ideally speaking, you should learn everything, but you have some constraint. Okay, so first 10 topics should be given priority. All right, so this is what is the syllabus content. Now let us review the weightage. So again, I have taken the statistics of last 10 years, ranging from 2014 to 2023 of all the 3 branch, electronics, electrical and instrumentation. So this is what is the exact data, how many questions they have asked from which particular subjects. So I have just taken it. So you see that in electronics branch particularly, like number of 1 mark question is around 2 to 3. Number of 2 mark question is also it is around 2 to 3. And the average weightage, if you see, it is 7.82. So on an average, you can see that around 5 questions to 7 questions is what you get. So you may say, sir, 3 plus 3, 6, but no, I'm going for, let's say, for example, like you say, this 2016, you see, 4 plus 4, 8. 8 questions are there, right? So, or even sometime in 2012, it was even more than that. So 5 to 7 questions is the range you can say in general, without including the exceptional cases. So 5 to 7 questions, and in terms of weightage, so it is somewhere around 6 marks to around 10 marks. So this is what is the weightage in electronics. Okay, so the highest weightage if you see, so you see 12 marks you got in 2016 set 2, and the lowest weightage you see that in 2019 you see only 5 marks they have asked. Only 5 marks they have asked in 2019. So, I have taken the lower limit as 6 and the upper limit as 10. So, this is in general the rough average I have taken, but exceptional cases it may vary. So, this is what is for electronics. And coming to electrical engineering, you see 3.2, that means 3 to 4 questions we are getting 1 mark questions, and again 3 to 4 questions we are getting 2 mark questions. You see the average is also high, it is 9.6. So I can say around 6 questions to 9 questions. This is what is the range of the number of questions. And in terms of weightage, so the weightage is somewhere around 8 marks to 12 marks. So this is what is the range. So this is again, I am not including the exceptional cases. Like exceptional cases, if you check students, the highest weightage is in GATE 2021. You see 16 marks they have asked. 4 1-mark questions and 6 2-mark questions. So 16 marks they have asked. Can you imagine from a single subject 16 marks of weightage is pretty high. And the lowest, if you check, the lowest is, I think the 7 mark is the lowest. In 2017 set 2 you got 7 marks, and even in 2014 set 2 you again got 7 marks. So I have taken it is 8 marks. So like in general around 8 to 12 marks you get from the electrical branch. Coming to instrumentation, the weightage is you see, like here it is again 2 to 3, here it is 3 to 4 you can say, and here it is like 8.66 is the average. So on an average, how many questions means the number of questions, it varies somewhere between 5 questions to 7 questions, again like electronics. And the weightage point of view, if you see, so it will be again somewhere around 7 marks to 10 marks. So this is what is the range of instrumentation. So this is for electronics, this is for electrical, and this is for instrumentations. So if you see all these 3 statistics, okay, so what I can tell is in general, irrespective of branch, so around 6 questions to 9 questions is what the range, I mean number of questions, and the weightage, if I check, it is somewhere around 7 marks to 10 marks. So this is what is the conclusion by analyzing the last 10 years of papers of all the 3 branches. But network is one of the special subject, students. It is basically a background subject that is needed to learn and understand concept of various other subjects. Without knowing the network theory, analog electronics you cannot touch. Without knowing network theory, electrical machine, power system, power electronics, you will have problems. So network theory and signal system, these are 2 basic subjects which is needed more or less directly or indirectly in almost every branch of electronics, electrical and instrumentation engineering. So from weightage point of view in GATE exam is very crucial. You see around 10 marks we can expect, and even its importance in other subject is also very crucial. So you should not take this subject lightly. And in fact, in my opinion, so who is preparing for GATE exam in electronics, electrical instrumentation, network theory is the first subject that somebody should learn. You should first start with the network theory, then something else. So 2 things I said. So what is the syllabus content? I have explained. This is the syllabus content. And secondly, what is the weightage? The exact data we have analyzed. So this is what the weightage is. So now this is the time to go through the each and every topic, what exactly we have to learn. Students, so GATE exam, like the what questions we'll get in GATE 2024 or 25 or 26 or 27 even you take, okay. So the majority of the questions, around more than 70% of the questions, so they will be from the previous year question models. In fact, you take the question papers of 2005 to 2020 and you then solve the question paper of 2021, 2023, you'll find that around 70 to 80% of the questions of 21, 20 to 23 are already asked in the question paper from 2005 to 2020. So I mean to say, because the syllabus is a static syllabus is not changed. So whatever the questions were there in the past papers, even present day around 70 to 80% we are getting the similar model questions. I am not saying that the exact questions we will get, but the model of questions will be very similar. So you should know like what kind of question they have asked in the past and what kind of question you can expect in the upcoming GATE exams. So chapter by chapter, so I have given the data. So let us see. So the first one is, friends, fundamental of network. Okay. Okay, and one more thing. Let me tell one more data. Okay. So among this, okay, so we said that around 7, like around 10 marks of weightage we can expect in the GATE exam, we said. But again, if you ask me, sir, there are 16 topics, which topic having weightage more and all, right? So if you ask me these questions, okay, so among the 16 topic, which topic weightage is more? So by observing the last couple of your papers, what I can tell is, so questions from the last 6 topics are very, very less from this topic. So you can expect hardly 1 questions in every 2 to 3 years. Okay, sometime it will be nil also. So questions from last 6 topics, hardly 1 question on an average you can take in every 2 years, or even you take, for the best possible case, you take every year one question from the last 6 topics. And in fact, these topics are very small topics, students. Filter, I takes hardly 30 minutes to complete this. Locus diagram also 30 minutes. AC transient also 30 minutes. Phasor diagram 1 hour. Magnetical coupled circuits 2 hours. 3 phase 2 hours. So hardly around 5 hours is sufficient to complete these 6 topics. Okay, so the content is less and the weightage is also less. Okay, so one question you get from this. So from fundamental of network, students, compulsorily one questions and even sometime more than one question you get. From network theorem also one questions we get every year. Then from fundamental of capacitor, inductors, step and DC response, and the network concept using Laplace technique, from this one question compulsorily we get. Sometime even more than that. Two-port network also one question compulsorily we are getting. Then sinusoidal steady state analysis, parameter of these AC waveforms, AC power analysis, and electrical resonance. So I cannot be again selective here. So from this, around 3 questions we are getting. Okay, so this topics, like this 7, 8, 9, 10, we say this is the AC network analysis. From this, around 3 questions we are getting almost every year. So if you see the number of questions, 4 plus 3, 7 plus 1, 8 questions I said. But the number of questions, like the statistic what we did. So 5 to 7 questions, 6 to 9 questions, 5 to 7 questions. So around 6 to 9 questions what I said. So this is what its corresponding distributions if you see the past year papers. And of course, we cannot say like in this year question will be framed from this concept, that concept. We cannot be that accurate in the predictions, because 16 topics, and if there are 9 questions to be asked, from which topic they will select, what concept they will select, it is very much unpredictable. But this is what the rough statistic I am giving, from which topic how many questions they are asking. Okay. And friends, let me tell you, to complete this course, I take around somewhere around 50 hours. I take the classes, okay, to complete the entire syllabus. And out of this 15 hours, the fundamental itself, it takes around 18 hours, the fundamentals. So this takes 18 hours, and this also takes somewhere around 16 hours. Okay, and rest of the hours will be taken by this. As I said, this takes 6 hours. So 6 hour plus 16, 22 plus 18 is 40, and this takes around 10 to 12 hours in general, I'm saying. Okay, so this is what is the number of hours I take to complete the course. So this number of hours should tell, actually why I'm telling you this information is, from the number of hour you can guess what is the content available, what is the intensity of the content available in every topic. So fundamental of network, you see there is only one questions, but we take 18 hours of time. It's because unless until you are not good in the fundamental of networks, so these all topics you cannot understand. So even though you don't get so many direct questions from this topic, but directly or indirectly in the next subsequent topics, you will not have comfort if you are not clear on the concept of the fundamental of networks. Now coming to what exactly like we get question in the GATE exam from fundamental is, so one model of question is resistance reduction technique. So they will be giving you some network which contains so many resistor. They will ask you what is the equivalent resistance. You might have seen this kind of problems in your 12th class also. So maybe something like this. So let's say a network is given like this. So like this they have given the network, and they ask what is the resistance seen from this point, what is the R equivalent. So this is one sample I'm giving. So there are many questions in the previous year papers. So these questions are known as resistance reduction techniques. And there are different techniques to find the equivalent resistance, like series parallel combination, using star delta transformation, or by using the equipotential concept. So there are around 5 to 6 techniques are there, using what we can find the equivalent resistance of a given networks. So this is, like we can say, like in every 2-3 year, one question you are getting from this concept, resistance reduction technique. And the nodal and mesh analysis, this is also very important, students. So generally, one questions we are getting every year in the GATE exam, like some network will be given and they will ask us what is this node voltage, or what is this branch current, or what is the power of this element. So when you get these kind of questions, most likely those questions are generally solved by using the concept of nodal and mesh analysis. So nodal and mesh analysis is very important. These are basically certain kind of steps we need to follow to solve a particular network. Then source transformation and inspection method. Source transformation, although there are not many questions, but yes, there are certain cases. Source transformation is to simplify the network. And what is the meaning of inspection method? Inspection method means a network will be given where you will be asked to find various voltage current. And so in those kind of cases, just by using KCL, KVL and Ohm's law, so you have to solve that network. In fact, nodal mesh is also combination of these. But these are kind of systematic approach to solve a network. In inspection methods, so you don't have to go through any systematic approach. You'll assume, let's say this branch current is I, then that branch current is I minus 1, like that. Using your logical approach, you have to solve those problems. That is called inspection methods. So many questions are there. You don't have to stick into this systematic approach. In some situation, if you go by the inspection method also, very quickly you get the answer. So source transformation and inspection methods. So from here we get questions. And lastly, energy sources and their interconnections. Like ideal voltage source, ideal current source, practical voltage source, practical current source. If ideal voltage source are connected in parallel or series, what happens? If ideal current source are connected in series, parallel, what happens? What are the source properties? So from there also there are questions. Okay. So sometime, I think in 2015 instrumentation they have given. So a voltage source VI characteristic is given like this. There are two voltage sources, one is this, one is this. If they are connected in series across a load, what is the current through that network? So unless until you don't have good understanding on the property of the energy sources, you cannot even think what this graph is telling you, the IV characteristic graph. So it is very crucial to understand their property and their interconnections. Okay, as I said, you get only one questions generally from fundamental of network. So that one questions will be definitely from these four segments if you see the previous year papers. Sometime the number of questions will be more, might be number of questions can be 2 questions or even sometimes 3 questions are also there from this topic, but without including the exception. So generally one question we get, and that one questions belongs to from these concepts. So this is what your chapter number 1. Okay, coming to chapter number 2 is network theorems. In network theorems, students, so generally 3 theorems from where we get the questions. So one is the Thevenin theorem and the Norton theorem and the maximum power transfer theorems. Okay, superposition theorem is also there, but questions from superposition theorems are relatively pretty less. And Thevenin theorem, Norton theorems, they are very much interlinked. Using source transformation, Thevenin model can be obtained from Norton and vice versa. And if you are clear on the Thevenin and Norton, maximum power transfer theorems also many questions you can easily solve. You just need to learn some specific condition for this particular theorems. But to answer questions from maximum power transfer theorem, you should have definitely idea regarding Thevenin, Norton, and particularly Thevenin, which is used very widely. Okay. And network theorem questions, so they can be from both AC network and from the DC network. Okay. So the questions can be from AC network and DC network, but the concept wise, Thevenin and Norton theorem, they are absolutely same whether it is AC or DC. But maximum power transfer theorem in AC, the content is pretty high compared to DC. In the DC case, we just learn one concept. If the load is variable, RL equal to RTH is the condition for maximum power transfer theorem. But in the AC network, depending on what element the load is containing, we have different conditions. So maximum power transfer theorem is having highest weightage. I am putting here 5 star. Okay, so the weightage point of view, you get many questions from this. And in Thevenin, I am putting 4 star. After maximum power transfer theorem, then the number of questions are more in Thevenin. And Norton theorem questions are relatively less compared to the maximum power transfer theorem and Thevenin theorems. But you should learn all these things. And again, if your fundamentals are not clear, your pen will not move in these theorems. So to learn these theorems, knowledge of the fundamental topic is must. So one question you get from the network theorems, and the questions will be definitely from these theorems. There are other theorems also, students, like Millimann's theorem, compensation theorem, and substitution theorems. Like this, there are another 4 to 5 theorems are there, but questions from those theorems are almost nil, I can say. So you focus on these theorems for both AC and DC. Now, the next topic is fundamental of capacitor and inductors. So this is a background topic to understand the transient analysis, students. In this case, so what you learn is the behavior of inductor and capacitor. Okay. So what is the voltage current relation? Like in a resistor, Ohm's law is V equals to I into R. So in inductor, V equals to L di by dt, or in capacitor, I is equal to C d by dt. How this relation is coming? Okay, and how to make use of this relation of voltage current if a question is given. So these all things we have to learn from this inductor capacitor. So this is a background topic for transient, and to be very specific, if you ask me, sir, what kind of questions we are getting from this topic? So one model of question you are getting is based on the waveform. That is, so they will tell if this current waveform is given to the inductor, what is the voltage waveform? Or if this voltage waveform is given to the capacitor, what is the current waveform? So one question we generally get based on the waveform. Other question is based on the energy. So they will ask if this is what a current waveform is applied to a practical inductor, what is the energy stored by this practical inductor? What is the energy dissipated by this inductor? Like that. Similarly for capacitor also. So energy related questions also sometime we get. And behavior of inductor capacitor for DC excitation and for the sudden jumps. You might have heard inductor doesn't allow sudden change in current, capacitor doesn't allow sudden change in voltage. For DC supply, inductor behave like short circuit, capacitor behave like open circuits. So those all discussions you learn in this particular topic. Okay. So sometime directly theoretical questions are also asked in the previous year GATE papers. So this is what the main three things that you should focus. So questions from this topic is not very frequent, like every year we don't get questions from this. But yes, there are questions, but not every year. But again, like if you don't understand the behavior of LC in this topic, then answering questions in the transient will be again challenging. So this is what about your fundamental of capacitor inductors. Coming to chapter number 4, students, this is what your step or DC response of RLC network. So this topic is popularly known as the transient analysis. This is known as the transient analysis. In the transient analysis, students, broadly I can say there are only two model of question you are getting. Although the chapter is huge, many of you feel that transient is a very tough one. But in a broad sense, if you understand the concept and you classify the questions what they are asking, so there are basically two model of question you are getting. One question is based on the step response of first order RC RL network, and the other one is response evaluation at t equal to 0 plus infinite. So what they will give you is they will be giving you a network, so which is containing one capacitor along with a bunch of resistor, or one inductor with a bunch of resistor. In those kind of network, they will ask you to find some voltage or current. So there are two popular relations like VCT is equals to VC infinite plus VC 0 minus VC infinite into e raised to power minus t by tau. Similarly, ILT is equals to IL infinite plus IL 0 minus alpha into e raised to power minus t by tau. Using these two equations only, majority of the questions of this segment you can easily solve. And there are some, when you learn those concepts, there are some supporting content of this, like the energy relation, the voltage current of LC elements, etc., etc. So you learn in the theory. So from there, questions are there, right? So, but what I'm saying is, so in a first order RC and RL network, so when they ask you to evaluate some voltage or currents, so that equation which I are discussing, using that equation, majority of the question can be solved. So you should have enough practice on how to make use of these equations. And the second model is response evaluation at t equal to 0 plus infinite. So a network will be given which may contain bunch of resistor, bunch of inductor and bunch of capacitor. So a network will have R, L, C components, and in that network, so you will be asked to find what is the voltage or current at t equal to 0 plus. Similarly, what is the voltage or current at t equals to infinite. If the input is DC or step, okay. But one thing, friends, in this entire topic, the input must be step or DC. The input should not be something else other than this. Input should not be sinusoid. Input should not be a square waveform. Input should not be a triangular waveform. Okay. So not like that. To be very specific, the input must be DC or step inputs. So with this excitation, so if the network, what is the response, what is the voltage or current at t equal to 0 plus and infinite. So again, there are some methods to solve this, so you should practice this. So only two model of question. One is the step response of first order RCRL network. One is the response at t equal to 0 plus infinite. So t equals infinity is the steady state response, and t equals 0 plus is usually considered to be transient state, so transient response. So how to evaluate this? So there are some methods, you need to follow that. So next in chapter number 5, network concept using Laplace technique. Okay, so here what happens is, if the network is containing R, L and C, and they ask you to obtain the expression of current, obtain the expression of voltage, in such kind of cases the Laplace technique is used. Okay, so in this topic, this is the first order I said. If the order of the circuit is not 1, it is 2, 3, 4 like that, and the complete response is asked, not the response at a specific instant. If the question is to find the complete response, complete expression of time, okay, so in that kind of case Laplace technique is used. Okay, but questions from Laplace techniques are generally less, students, and there is a reason for this, because the questions in this Laplace technique are basically what I can say is lengthy. They are lengthy questions, and in GATE exam generally they don't ask the lengthy questions. So hardly, if you see the 30-year papers, so 5 to 6 questions you may get from Laplace techniques, because they are lengthy, so we don't get so much questions. Coming to the two-port network, and as I said, so you get definitely one question from these and these 3 topics. Two-port network also compulsorily one question we get, and that questions will be from any of these 6 model. Definition of 6 types of parameters. Okay, so there are 6 kind of parameter like Z, Y, H, G, then capital ABCD, small ABCD, like that. There are 6 kind of parameters. So what are the equation? Like in Z parameter, B1 is equals to Z11 I1 plus Z12 I2. Like that, these set of equation for all the 6 parameters you should definitely know. Secondly, there is something known as condition for symmetry and reciprocity. From this segment, every year questions are coming, and these questions are memory-based questions. So what is the condition for symmetry? What is the condition for reciprocity? When a two-port network is said to be symmetrical, when it is said to be reciprocal. So you should have, definitely you should memorize those conditions. Interconnection of two-port network. So there are 4 kind of interconnection: series, parallel, parallel series, parallel, and cascade. 5, not 4. 5 kind of interconnection. So you should know, like in a series interconnection, Z parameter can be added. In series parallel interconnection, your H parameter can be added. In cascade combination, T matrix can be multiplied. So these all concepts you will be learning in this interconnection of two-port network. Next, interconversion of two-port parameters. So if a Z matrix is given to you, how to get Y matrix from this? If a Z matrix is given to you, how to get G matrix from this? So these are called as the interconversion of two-port parameters. And next, standard two-port network. Like what are the like Z matrix of, let's say, a T network? What is the Y matrix of a pi network? Then there is something called lattice network, transformer. So these are certain cases. So these are some standard network. For what you should know certain two-port matrix. If you know that, majority of the gate questions are framed from those networks, your solving steps will be reduced. You can answer that questions in less amount of time. Okay, what are the network? T network, pi network, lattice network, and your transformer. Okay, so these things you should memorize. To be very specific, T, pi, and lattice network, definitely you should memorize this. And lastly, the terminated two-port network. Terminated two-port network means a two-port network will be like this, and it will be terminated by a load. Okay, it will be terminated by a load, and this is excited by some source. So they will ask you some voltage current of this load or the power of this load. So such kind of network I name as terminated two-port network. So one questions, you can see like in every 2-3 years, one question is coming from this concept. So overally, from this 6 concept, one question you can expect in the GATE exam. If there is a single question from two-port network, so that questions will be definitely from either of the 6 category. Next is the sinusoidal steady state analysis. In this sinusoidal steady state analysis, students, so generally a new concept that is called concept of phasors you will be learning. Okay, and secondly, the circuit solution using phasors. So a network will be given, a RLC network will be given. Let's say the network is like this, and this is excited by a sinusoidal source. Let's say 2 sine 4t minus 45 degree, and you'll be asked to find some voltage or some current in the network. So these kind of problems I mean by circuit solution using phasors. So the same RLC network, excitation will be AC. So if excitation is AC, you have to use the phasor, and then by using different techniques, what you have done in the fundamentals, voltage division, current division, star, delta, mesh, nodal, using all these concepts, you have to find some voltage or current. So that is what I mean by circuit solution using phasors. Next, parameter of AC waveform and time varying waveform. So sometime in the GATE exam, we find the questions, some waveform will be given, let's say something like this. So they will ask us to find its RMS value or average value, something like that. So these all things you'll be learning in this topic, how to find the average value, RMS value of a waveform. And here there are two more concepts, the form factor, okay, which is the ratio of RMS to average, and the peak factor, which is the maximum value to the average value. Sorry, maximum value to the RMS value. So peak factor and form factor. So these concepts you'll be learning here. And here in this topic, student, to be very specific, a expression of x of t will be given, which is sum of different sinusoid of different frequencies, and they will ask you to find the RMS value of that expression. So whenever you get such kind of questions, so that is what is the approach you should take. What is the approach you like to take this? So you should learn this from their questions you are getting very frequently. So sinusoids of different frequency, when they're added, what is their RMS value? So such questions are very repeated. You should definitely pay special attention to that model. So this is what you learn in the parameter of AC waveform. Coming to the AC power analysis. So here basically this topic is formula based topic, students. So a network will be given to you and you will be asked to find what is the average power, reactive power, apparent power, complex power. So these are different kind of power we speak about in the AC topics. So for each power calculation, we have some specific formula. You should know how to make use of this formula. Okay. So formula you should know, and how to use them you should know. And here you will be learning the concept of power factor. What is the power factor of resistor? What is the power factor of inductor? What is the power factor of capacitor? So these all concepts you will be learning in this particular topic, AC power analysis. But yes, its weightage is also good. So like in every 2-3 year interval, one question you can accept from AC power topic. Then coming to the 10th topic, which is the electrical resonance. So resonance, so there are two standard circuits from where 99.99% of questions are coming. And those are series resonance circuits and the parallel resonance circuits. Resonance is such a topic where I can say that 90% of the questions are formula based questions, friends. If you know the formula of resonance of series RLC circuit and parallel RLC circuits, 90% of the questions you can easily answer, because the questions are straightforward formula based questions. There are few exceptional cases, otherwise they are the formula based questions. So without knowing the formula, these questions you cannot touch. So while learning the concept, how the formula is coming, how it derived, you should pay some attention to that. But majority of the questions are the formula based. And broadly, there are two circuits only, series RLC and parallel RLC. You should learn the formula of that. What kind of formula? There is something called what is the quality factor of RL element, RC element, series RLC element, parallel RLC elements. Then what is the bandwidth formula? Then what is the upper cutoff frequency formula? What is the lower cutoff frequency formula? Then you have what is the current voltage expression of various element in the circuits. So these all, like I think around 20 to 30 formula will be there, by including all formula. So if you do practice, automatically you will memorize. So questions are there from these segments. And as I said, from the last 6 topics, the weightage are generally less. So to be very specific, again, what kind of question they ask. So I have just written here. So from the filter topic, they ask, identify nature of filter. So a network will be given to you, or a transfer function will be given to you. So they will ask, this particular network or this particular transfer function represents what kind of filter? Low pass, high pass, band pass, band stop. So you have to answer it. So how do you answer it? By taking the frequency omega equal to 0 and by taking the frequency omega equal to infinite. So just by testing in these 2 points, most of the cases we can identify what kind of filter it is. In network, we learn the passive filters, which contains only RLC elements. In analog circuits and in other subjects, you may learn the active filter, which uses some op-amp or some amplifiers along with RLC components. Okay, but in networks, it is pure RLC network. Just by testing the behavior at omega equal to 0 and infinite, we can conclude what kind of filter this is. Locus diagram. So locus diagram is something like this. Let's say a RL network is given and is excited by AC source, and here let's say R is varying. If R is varying and my interest is the current, so how does this current varies when R varies? So when you vary the R, what is the current, how it varies, what is the magnitude and phase, how it varies. So if you plot those points by taking different value of R, if you find magnitude and phase, and if you plot them in polar coordinates, so you get a trace like this. So this is called the locus diagram. So locus diagram weightage is not much. I think in every 5 to 6 year, one question you may expect from locus diagram. Weightage is very less. In AC transient, there is something known as condition for transient free response. So there is only one specific condition. So from there, sometimes questions are asked. Sometimes it's very, very less. In the 35 year of history, if you check, 2 to 3 questions are also not there from this. One questions, or I think once or twice only they have asked. So it is very, very less. So here you have to learn only one condition for transient free response. Next, phasors. So in the phasor topic, you should learn how to draw the phasor diagrams. Phasor diagram of series RC circuit, phasor diagram of series RL circuit, phasor diagram of RLC circuits, okay, and the parallelogram law of vector addition. So these are certain concepts you should learn in the phasors. From this topic, although I can't say, every year you get questions, but yes, so you need the concept of phasor diagrams while analyzing the questions in the AC network analysis. So you should not skip this topic, okay? So this you should must learn, and even your machines and all, where very frequently you deal with the phasor diagrams, without the knowledge of phasors, it will be quite challenging. So you should definitely pay attention to this. Magnetically coupled circuits, only there is something called dot conventions. So dot conventions of series network and parallel networks. If two inductors are in series, what is the equivalent inductance by considering the mutual inductance? Similarly, if they are in parallel, what is the equivalent inductance? Consider the mutual inductance. So depending on the dots where it is placed, so the inductance varies. So you have to learn this. And here one more concept is there, the energy relation. So I think last year, so based on this energy concept, one question is there in the electrical. But weightage is again less, students. In every 3-4 year, one question you may expect from this concept. And three-phase network. So particularly for electrical students, this is important, students. Almost every year, one question we get from three-phase network analysis, coming to electrical branch only. So in three-phase network analysis, the star connection and delta connection of both source and load you should learn. The corresponding line current, phase current concept, and line voltage, phase voltage concept, and even if possible, the three-phase power. So this is also needed. So from this, you can expect questions in the GATE exam, in electrical branch specifically. So this is what is the overall content of the syllabus, students, and in each topic, what kind of questions you can expect from which concept I have highlighted. So I believe this video is helpful to you. If you have any queries, you need any support, I'll be happy to see your comments in the comment section. Thank you. I'm closing this video here, and we'll meet in some other video in the upcoming days.